Okay, hello everyone. Okay, it's a great day. So today we gonna finalize the access control. Maybe the module due by tomorrow. I'm not sure. Um, see, and then we will start binary exploitations. I'm not sure. Anyway, so we are now walking through the access control mechanism depends on the feature. So who controls or control what? So based on that, we can model and also uh, implement based on the features uh, to enforce that mechanism. So today, in the last class, we covered some like a ACL based access control or capability based access control. So what else? What other ideas for access control? So today, so we will some more practical and applications of access control model. Basically, there's a two the concept to division of these control ideas. The first one, content dependent control. So these controls restrict access based on the actual the content or attribute of the data. So the given example include like here you can only see salaries less than 50K. So that's a content, right? And you only see salaries of employees who report to you. Like only my group members report to me. I can see only salary for him, for them, or like the doctor and patient. Only the doctors assigned to the patient can see the chart of that patient. Like that, based on the content, that we can set the policy. We call that the content dependent control. The other one is the context dependent control. What's the mean context? So context, yes, how, when, where. So there are factors to describe some circumstance, situations. So that control consider this context in which the access is being recast. So, example, like cannot access sensitive information from a remote login. Usually we set that like that, and cellular information can be updated only at year ends because they have to be report tax, filing tax. Like that, based on the context, we can set the policies, and company's earning report is confidential until announced in the meeting. Okay, so this idea, uh, we can get some dynamic or some situational access control model uh, beyond the what you learned about the like ACL, the access control list, or the capability based access control. So there are more examples regarding this content or context. What are you thinking about the first case? The doctor can access patient records only if they are currently treating the patient. So what do you think about this? Is it context or content? Yes. No. Content based, right? So the patient must be the patient of that doctor. The doctor can see only his record based on the content, right? And how about second one? Yeah, the employees can only access sensitive informations connecting via VPN. So because of the employees using, they use the VPN. Oh, so they have secure channel, so they can see that they can access that information because they have the secure uh, measure, secure way. Third one, the bank employee can view transaction record only if they are part of the fraud investigation team. The same with doctor's example, right? And last one, the anomaly in under behavior, such as trying to access data at unusual hours, like 4 a.m., 2 a.m. They try to download some large volume of data. So this is the kind of story, right? So the situation-based, context-based access control. In this way, depends on the situations or any some requirements. So we can set the model. What is this more appropriate? The content based or context based. In the context model, in the access control model, we usually there's some famous the model, uh, mechanism or the mechanism. The first one, discriminatory access control or DAC. What is a DAC? What's the meaning of discriminatory? Discretionary. So user, the owner can determine the policy of the access control, who can access the object. And second one is a MAC, mandatory access control. Who can control? The system admin or some policymaker, they can control the access the object. The last one, the ORBAC, originator controlled access control. So what is different from the DAC? So not owner, only originator. So the like intellectual author, or the creator of that property determine the access control policies. So this is the tables comparison between DAC and ORBAC. As I mentioned, the control entity is different. The DAC is owner, but ORBAC, no matter what, the owner, the only originator, the creator can decide, determine the access controls. In this case, like yeah, intellectual properties, like any some the movie or drama, videos, and the music. So the creator can determine the access control about that creative work. Granularity. So everyone understand the granularity, right? Granularity, the basic unit to access. Uh, so DAC, they only support like a read, write, execute. Where did you see this? Where did you see these permissions? Read, write, execute. The Linux, right? Yeah. So Linux, they are based on the DAC systems. So user can set the permissions for user group others, right? 777, 700, like that. They can set the permissions what they want. So the Linux, they delegate the control to the user owner. So that is the DAC. But yeah, ORBAC again, ORBAC, uh, that is the more advanced permissions by considering roles, activities, and organizational context. Okay, and flexibility. That is flexible for the owner, but can be complex to manage at scales for large system, large organizations, enterprise, like that. So we need to draw the access control metrics for everyone. So user from user 1 to 100,000 millions users, and read write, like OWG. So that is a very the burden of the management. So in the case, the flexibility very low in DAC model, but rollback can be more complex, allowing for sophisticated organizational policies. In terms of security, so the DAC are potentially less secure than uh, the rollback because the permission can be freely changed by owners. So the mistake of the owners can be the vulnerabilities of the system, right? And rollback are potentially more secure than a DAC because control is maintained by the originator, the creator, right? There is a difference between that them. Okay, let's break down one by one. The first, the MAC, the mandatory access control. Mandatory. Seems like a stick, right? Um, so in Mac model, they set the clearance level, the security levels like a top secret, secret, confidential, and the unclassified. They can also define the categories, the human resource or legal financial research. So combine them and tag for each subject and object, and they make that relationship between two entities, subject and object. So they maybe there we can extract the permissible relations and unpermissible relations from the relations tables, right? This way, so which organizations or where is good for these kinds of systems? Top secret, secret, confidential. So yes, military, right? Military or government agencies like FBI. So we can see these mark or labels in the movie. It's like a spy movie or right. So very strict and labeled anything, labeled everything, and they can uh, to protect the confidentiality of the resource. There's a basic way. Okay? Government and military environment is a they prefer use these kinds of model. So what is the security level again? Um, so basically, security level that's our relationships, hierarchical relationships like top secret and secret and unclassified like that. So state many organizations have a hierarchical relationship between the security, the sensitivity maybe, or yeah, secret sensitivity of their the asset or the resource or the human. Okay, so it means the information and resource are classified, right, according to these, uh, the based on their importance, and they have to keep them secure. So it means it might be highest security sensitivity, indicating uh, that are not all assets are not equally handled, right? So only file might have the highest security sensitivity in the office environment, maybe memos, report, customer list, backup data. So this is the example of the asset of some organizations, right? So these kinds of documents can be maybe the confidential or the personal informations or some proprietary informations. Okay. So the security level defines sensitivity and importance of the asset of organizations. Okay. Top secret and secret. So let's focus on concept of security levels again, and let's see it in computer. So need some way to tag data on a computer system. So yes, so in this way we can have some mechanism to tag data within our computer. So tagging is a way to classify based on the the sensitivity. Okay. Sometimes we can consider the relationships like the one-to-one mapping or one-to-many mapping. So these relationships show how to organize or how to make a policies based on those relationships. Um, so by considering this way, when we implement the security levels, we can make more secure and flexible to the users using these categories, classifications. Okay, let's see example. So in commercial security level sectors, commercial sectors, the restrict, so top priority, and proprietary, and then sensitive, and public. Okay, so public is not secured, not classified. How about the military security levels? Security levels, top secret, and the secret, confidential, and unclassified. Okay, this is the example of secret level. Okay, so this secret level is a give us a way to classify the informations or asset uh, to be managed appropriately. Okay, let's discuss the policy, how to implement this mandatory access control model. What policy do we want it, our Mac to enforce? Okay. Again, let's see in a military example, top secret, confidential, unclassified. Now we are going to use some formal model symbol notations. Okay, so large L takes subject S. It returns what? The level. This here not Li. This is the L, right? So level of security. The return, this function's return L, level of security, is the security clearance of subject S. Okay. And another one is the object, the subject and object in access control. So L, the level of large L takes the large O, the object. It returns the level of security object O. Okay. So all security classification is one of these level, the Li to Ki. K minus one, that can be a top priority, top highest level, right? So this is basic the definitions in a way of some formal model describe the rule and policy, and then let's define some security conditions. First one. So these conditions we will revisit again later. These conditions I brought this from the Bell LaPadula model. There's two conditions. The first one is a simple security condition or SS conditions. The other one, so we call that the star property. Uh, what is that? So simple security conditions. So subject S can read object if only if level of O is less than or and or equal with the level of the subject. So that is the straightforward, right? So I can read with my same level of object and also less than my security clearance. I can read that object. That is the simple security condition. So we call that no read up. I can read up more than my security level. Okay, so that is the security, simple security condition. First one, SS on property. Second one is a stop property. Subject S can write object if the level of security is equal with the level of object, or the less than the level of the less than uh, the level of object. What does it mean? So yeah, so the two conditions. The first one, SS properties like that. I can read if I my sequence level sensitivity. I can read the property level, right? If I have a confidential level, I can read the secret level, right? That is the first simple security property. So we call that no read up. Okay, only we can read down, no read up. Second property, so that is the no write down. If I have a secret layer, secret level, I can write anything down to the confidential layer, confidential level. What's the mean? So I have secret. I have a level of secret, but I cannot write down to the confidential security. What's that mean? Higher level cannot flow to the down layer, right? So the information cannot be leaked from the higher to the lower. So that is a basic philosophy. So we call that no write down. So the confidentiality is so critical in this model. If I know some uh, critical informations, I cannot say that to the guy in the low level of security guy. Make sense? Okay. But it is not always work. So this model, as I said, Bell LaPadula model, but the opposite model, there's one model is Viva model. In Viva model, I can write down anything to the low layer security level. But anyway, so this is the one of great examples of MAC, mandatory access control model. So again, simple SS property, so no read up, and star property, no write down, that we call the star property. So military or government agencies, FBI, they they employ these conditions to make their policies of access control. Okay, no read up, no write down. So typically, the security clearance, the level, so we can define like that: the top secret, uh, and what is that? The other one, uh, unclassified like that. So that is not enough in some cases to support some more fine granularity. So we can add one more parameter. We can call that the categories. So yeah, security levels are two coarse grain. The coarse grain is opposite word to the fine grain, right? Coarse grain is our pores too big, so that's not enough to describe some details. Um, So we add the, the categories. So here, example, we add the three categories NUC, the NATO, and ACE. So what's the meaning of these category names? I can guess, but I'm not sure actually what is that. But maybe the NUC means nuclear in military. The NATO, that's the name of the organization, right? But I don't know what is the AC, ACE. I don't know. Okay, so there's no priority, but it has a unique the classifier. This is the unique classifier. So we can uh, classify the security, the clearance based on these parameters. Parameters. So first one is the security uh, level, and another one is the categories by combining them. So we can call that the tuples. So okay, how to define the security policy now? Okay, let's use again the notations. So subject security level and object security level is now L C tuples. This is the level and C is categories. Okay, so L is the level and C is the set of categories. How to compare subject S1 with object O1 for access. So we can use the lattice module. There's a module here. So from the bottom, this is the just the empty curly brace. So empty that is defined as unclassified. So this unclassified can be part of the upper uh, upper layers, the NUC, NATO, and ACE. That is the category, right? We define. And also these three categories can be a subset of the upper layers. Like this NUC NATO has the subset NUC and NATO, right? And also NUC ACE, NATO ACE. So in the like a root node in the top, it has all category of all categories. So based on that, we can see so each node has some relationship. So we call that dominations. So you can see the dom. So domination means yes. So this category is part of the upper layers, upper categories maybe. So the NUC in this case, NUC is the part of the NUC NATO and also NUC ACE, right? So this the directions line, the line means the has a relationship of domination. So these categories dominate these categories. Okay, and also these two categories is a part of the these categories. So this top node dominate, this subset sub node dominate. Okay, so based on this, we can define the, the conditions in the previous model, the military. We can say the two conditions. So il appelle la Padula model. The security level at C tuple dominate the security level L prime and C prime. If L prime the less than and equal with the L. So L prime can be a subject and this L can be a object. Object of layer, the security level, and subject security level. So subject security level equal and less than or less than to less than with the object layers, and then the categories. So what's the meaning of this symbol? Is a set of C, right? So if the subject categories is a part of the set of the subset of the C set, so this is the kind of uh, if condition, maybe a condition statement, maybe in programming, so we can judge uh, does L and C can satisfy with these conditions. Okay, so based on this the functions can return the true or false to satisfy with these conditions, right? So the first condition and the next conditions we can check. So simple security condition, SS property, right? So S can read object if S DOM O. So this DOM means this line, the first line. Okay. So L prime and SC prime can be a part of can be a equal or less than and the subset of the object. In the case uh, that a simple security condition is satisfied. Okay, so in the case S can read O object. Okay, because subject dominate O. And stop property, S subject can write to O if or dominate S. So the no write down, right? So S can write to O dominate S. So object O, if object O um, dominate this condition, right? So dominate is less than S or equal and the subset of the subject. In the case, the subject can write to the object. That means write off only can possible, right? No write down. So these two conditions uh, indicate no read up, no write down, only read down, only write up. Yeah. So in our challenges from maybe 15 or 16, 17, 18, 19. So you have to make this with the functions and evaluate some conditions and return that the result to the process. So that is the way to get the flags in our challenges. Okay, let's have some examples to make decisions. Uh, we have some pre-assumptions. A has top secret and ACE category. B has secret and narrow and ACE categories. Okay, first, can A uh, read top secret and uh, empty categories? So in this case, the read of this TS and empty categories of object. Okay. So what do you think? Can I read the top secret empty categories? Yeah, true, right? Because the subject A has the top secret higher than the same with the object TS, right? And this category include the empty category, right? So subject A can read the TS and the empty category. Second case, write object with a secret, clearance, and AC category. So the A has a top secret, but this object has split S. Is it possible? No, no right, down, right? So top split and split, that is the write down. So this is the for first. I cannot write to the object with the S clearance, right? How about this? As subject S can read top secret, has the category NATO and ACE. Okay, so top secret and top secret same. But how about the category? The ACE. But yeah, A does not have the NATO category. So A cannot read this object. How about this case? All right, object top secret, ACE, and NATO. So possible, right? Because A has TS, the TS same clearance, and category ACE and ACE, right? Because the subject is a subset of these categories, subset of this category, right? So it is true. Okay, let's change subject to B. Okay, can B write object O with script clearance level, skill level S and NATO? B has a skill level S, right? So S as same. How about categories? B has a NATO and ACE. So B has a NATO. Is it possible? Yes, possible, right? So B has a category NATO, so he can read. Okay, good. So read down is possible. But this case, um, subject B read top secret. True? No. Yes. No read up. So first, good. Oh, how about this? B can read S, the category ACE and NOx. Can you see? What do you think? So category is different, right? So security level is same, but the category, the B has only NATO and ACE, but B has a category ACE and NOC. So subject B doesn't have this category NOC, so he can read in this case. And last one, right? U. Okay, because B has the S split, and right U is a lower level, right? So is it possible? No, he can write down. No write down. Okay. Yeah, this is the example of in the Bell LaPadula model. Again, so in the challenges, you have to make these functions to return the true or false, yes or no, to the questions. Okay, what kinds of other access control? What types? So access control has a long history, and various types of models are published. and that depends on some uh, the feature or characteristics of the business. They choose one of them, or they combine like a hybrid the model. So like a Linux model that we can see they use a deck model, so user can define, but sometimes they define the group role and assign that to the users like that. That is not DAC or Mac, so that we call that the role-based access model. Okay, so we can define the users, uh, the the group. So users permissions are determined by the users roles. The, the based on the group, one of the group. So I'm a faculties or your students. So based on that, you got the permissions, right? So doctor and patient and nurse, and they have different access policies like that. Based on the role, we could define the access policies. Okay, so the rollback rather than identity or the clearance MAC. What's that mean? So in the rollback, the permissions they are not determined by the user's role within organizations, not by the individual's identity or security clearance. Like that. Oh, yeah, just permissions are determined by the user's role, not by the identity or the clearance in the Mac. This is the more natural expressions of business logic. Another one, ABAC, the attribute access control. So what is the attribute? So um, so in this case, what is the attribute of this access control system? Is a height, right? So that'll be the attribute of this access control. How about this? The age, right? How old are you? That is the access control factor. This case, it's identity or a certificate. In this case, the gender. That's gonna be the attribute for the access control decision, right? Like that, attribute based access controls are very flexible and popular in the access control domains. Um, so you should have attribute, age, ID number, group membership. Okay. So police is a complex Boolean expression on attribute. So one of my research regarding the access control in what's that? Pokemon game, Pokemon Go. So Pokemon Go, you have to capture some images, images in the real world space, right? Sometimes in the real world space, as a owner of the space, I don't like to allow them that play the game. So augmented reality games. So I like to block the players in my area. How can you do that? So I like to set the time because my work time from the 9 to 5, I don't like them play the game because so noisy and crowded people. I don't like that. And also after 6 p.m., only uh, over 18 years old, I like to allow them play the game. Like that, we can set the different attributes to enforce the policies. In that way, the owner of the space, the make the decision, the policies based on the attribute. So in the research, we design the framework and implement uh, the pilot games, and yeah, that was highly evaluated to the reviewers. Those are good ideas. How about the metaverse or the virtual space? So can you design X control model such a space in your what is your favorite games or what is your virtual space? So access control is very great topics for research. Okay, so in terms of usability, flexibility, expressiveness, federations. Sometimes of the expressiveness. So one of our the key point in our research, how the normal user, like a non-CS students, non-computer science students, or non like expert in the access control, how can we make them set the policy without any mistakes, like intuitively and straightforward setting? How can you make them that? So that is the relate to the usability or the expressiveness. Okay, so allow or deny, reject, close, open. There are a bunch of terms in the controls. So what is the most familiar to the normal user, non-CS students, non-CS people, non technicians? So yeah, that was the one of the point in my research. Okay, federations. So ASU, UA, and NAU, different university, but they are state university, right? That means they use some common infrastructure. That maybe one of them is like a GPU farm, a supercomputing resource. But to use the resource in other university, how to authenticate them, how to get the certifications from different university. So in the case, let's make them some federate framework having compatibility between two different institutions. Okay, in that way, so we can give some compatibility. We call that the federation access control, federated access control, like that. Okay, so that is also the great topics. Okay, that's all. Um, yeah, let's visit some. Okay, 2 days, 1 hours. 1 day's 11 hours left. If you are familiar with the Linux access control mechanism, so this challenge is very easy. Maybe in the challenge 11 and 12, so they make us find the flag using multiple users. Okay, so in this case, how to switch to the users. So one of okay. So let's launch challenge and run. Okay. They give us some account and password, right? User W, user Y with the password. So they give a hint. Copy of the flag has been placed somewhere on the temp. So you can see the temp directory. Okay. Yeah, here's the temp. So you can see the different user defined as the groups, right? So user R, user Y, right? So you need to change to this user to visit, navigate to this directory. Okay. Let me try the cd temp user. Wait, cd temp. Hmm. So we can access the temp directory, but so this directory owned by root and the group users can access. The name of the user should be this user Y. So that's the reason why we cannot access this directory. Let's move the temp book and user. No such a file. User. Okay, so we need to change our count to these specified users, right? So already the challenge give us these Y users and password. How can you change that user count? Right. So su command, right? So su is a run a command with substitute user or group ID. So option and the user arguments allow to run command with a substitute user ID. That means as you use blank and usernames, that means we can switch that username account, right? So options dash C. And what is this dash? So we can use user yi and gbb. They ask a password, so you can type the password here. Let's try. Okay, interesting. So they show the different user ID, right? So not the same directory. Okay. So there's some different directory. So using the SU commands and switch to that user, try to access some directory and files. Okay, so in this way you can avoid, you can bypass the access control using the su command su. Okay, so as a tip, so the different of the su dash. What's the meaning of su dash? And if I type username, so slash or the dash means they make the logon with the same variables, the environment variables of the usernames, okay, like a profiles or some the predefined configurations that will be applied. If you use the dash options, so that allows the logon with the same variable environment variable configurations. Okay, that's the tips. Okay, so number 11 and level 12, so almost the same. Okay, so from level 13, they make one mandatory control questions without categories. So you can again. This is a normal. Yeah, too long. Jump to level 14. Okay, Docker failed. We need to contact corner. Okay, unfortunately we cannot see challenge now. Anyway, from okay 16, no no, I think the yeah by level 16, every questions were very easy to answer. However, yeah, from the 17th, you should answer the 20 questions in a 1 second. What's the mean? 1 second. So you cannot answer manually to the questions. So you need to use um, the phone tools. So process functions. So give us the input interface, right? Pipelines. So we can send the answer to the process automatically. Yeah, based on the functions you made, the functions that is the Lapadula model. So two properties. The one is the simple security properties, right? SS, no read up, and the other one, no write down. Star properties. So you have to implement these two properties, and you should read the questions from the challenges and input that uh, conditions to the the functions you made to the Lapadula model, and based on that, you have to answer yes or no automatically to the process. So that is the basic schemes to solve uh, the level 17, 18, 19. Yeah, in this way. So they give us the assumptions, pre-assumptions, right? And then the kind of subject with UC and categories, right? The object with the C of categories. So alarm clock, because you have to answer in 1 second. In level 18, 64 questions. In level 19, 120, 128 questions. I don't think it is the access control challenges.